Though today's class will not be on the test, the beginning of it, we're going to use the tools of transformations to develop some new formulas. So we're going to be reviewing transformations a little bit today. So this part, the transformation stuff, will be on the test. Just that's really not like the punchline of today's class. All right, so today we're going to talk about quadratic functions, and a quadratic function is any function that can be written as ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0. And the graph of any quadratic function is called a parabola, and the parent of all quadratic functions is x squared. And we all already know what x squared looks like. We've worked with it a lot. The point 0, 0 on the graph of a x squared is called the vertex of x squared. It's that minimum point or the turning point where we switch from decreasing to increasing. All right, so we are going to graph the function g of x, which is 2 times x minus 1 squared minus 3 by transforming the graph of x squared. So let's just list a few key points on here. So one important point would be 0, 0, right? So that's a really key point on this graph. What's another point where that it goes through? 1, 1. Yep. Or 2, 4, or 3, 9. Let's use 3, 9, and -3, 9. So we're just going to use those 3 points, and they're going to basically dictate the position and shape of the graph. I could use more, but just for saving time. Okay, so there's several key points on the graph of my parent function. All right, I want to determine where these points go when we transform f into g. So when you look at this function g, what's the first transformation we have to do? The -1. You always do the horizontal shift first. So that -1 means I'm going to shift the whole graph right 1 unit, right? Okay, so how do you change the x values if you're going to shift right 1 unit? Add 1. To go to the right, you have to add 1. Okay, so this is going to become 1, 0, 4, 9, and -2, 9. That's my right one. All right, and then what transformation do I perform next? The multiply by 2, which causes a vertical stretch. Okay, so to create a vertical stretch with a factor of 2, how do you change your coordinates here? Multiply each y value by 2. Okay, so from here, I'm going to have 1, 0, because 0 times 2 is still 0. This is going to become 4, 18, and this is going to become -2, 18. Multiplied each y value by 2. All right, and then the last transformation is at -3 down. That -3 is outside, right? So it's a vertical, so it's down 3. So how do you change the coordinates of a point to move it down 3? Subtract 3. So this is going to become 1, -3, 4, 15, and -2, 15. So I'm going to plot those 3 final points. I've performed all my transformations, and 0, 0 is now going to be at 1, -3, and 3, 9, this point here is going to move to 4, 15. 4, 15 is like right there, and -3, 9 moves to -2. Yeah, -2, 15. There we go. Right. Yeah, right. Okay, so when I connect these, I get my new function, g, that is a transformation of f. So where did the vertex end up? That low point, 1, -3, right? Okay. Could we have identified the vertex as 1, -3 just by looking at this equation? Is it hiding in there somewhere? No, because if you plug in 0 for x, you're going to get the y-intercept. Yeah. Then there'd be nothing left to solve for. Right, but that's not true, right? Yeah. Yeah, right. Is that what you're going to say, Tony? There's a 1 and a -3 in the equation. Here's a 1, here's a -3, right? So by looking at that equation, I could identify the 1 and the -3. I can identify where the vertex is going to land after all my transformations. The 2 didn't matter, right? That -1 says shift right 1, and the -3 is down 3. So my vertex moved from 0, 0, right 1 and down 3 lands me at 1, -3. The 2 doesn't make any difference because when you multiply 0 by 2, it still stays 0. Okay, so I could read the vertex right from the equation. This is called the standard form of a quadratic equation. We just did an example of looking at one. A times x minus h squared plus k. What transformations from the graph of x squared does this standard form represent? Yep. There is a vertical and a horizontal shift and a stretch or shrink depending on the value of a, right? Vertical stretch or shrink. So this is a horizontal shift, h units. Right or left depends on the sign of h, right? If h is positive, we would go which direction? Because there's already a minus here. So if this said x minus 3, right, we would go right. So h doesn't include, that subtraction sign is part of the formula, not part of the h. Okay, so we have a horizontal shift h units, a vertical stretch by a factor of a, and then we have a vertical shift by k units. Okay. So we can analyze this standard form of a quadratic from the standpoint of transformations, and having it in this standard form is convenient because we can immediately identify the vertex of the parabola as h comma k. And if a is positive, what does that tell me about the parabola? Does it open up or down? Up. I mean, so if a is positive, it looks just like regular x squared and it opens up. And if a is negative, the parabola would reflect over the x-axis, so it would open down. If a is small, the parabola is going to open more flat because it's going to be a vertical shrink, which is going to like flatten the bottom. By small, I do mean less than 1. Yes, thank you. Then if a is large. And then if you're trying to sketch a graph, finding x and y intercepts can also be helpful. So let's do a little example where we sketch a graph of a quadratic function. And this time it's going to be a little bit easier than doing this transformation business, because now we know that we can just pick out the vertex right away. Okay. So first I want to locate the values of a, h, and k in this formula. So what is h? 1, good. Because the minus sign is part of the formula, it's part of the equation. 1 is the h value. What is k? 4, good. And what is a? -1, good. So what's the vertex of the parabola? 1, 4. So you could think of this as transformations also. This says right 1, up 4, so your vertex is going to be at 1, 4. Move from 0, 0 to 1, 4. Does the parabola open up or down? Down, because the a value is negative. How would I find a y-intercept of the parabola? Put a 0 in for x, good. So f of 0 would be -0 minus 1 squared plus 4. So 0 minus 1 is -1. And when you square -1, you get +1. But then I have a negative on the outside, so it becomes negative again. And then plus 4, and I get 3. So I've got a y-intercept of 3. And then how do I find x-intercepts? Plug in 0 for y, or for f of x. So I'm going to have 0 is -x minus 1 squared plus 4. And I want to solve this for x. Any ideas? Any memories on how to solve this thing? If I subtract 4 from both sides, I would have -4 equals -x minus 1 squared. Okay, now what? If I divide by -1, I can get rid of all my negatives. That would be nice. So 4 is x minus 1 squared. Good. Square root. Yeah, I can undo that square by square rooting. And so the 4 becomes plus or minus 2 when I square root it. And then x minus 1 squared square rooted is just x minus 1. Add 1 to both sides. And we get x equals, yeah, +2 plus 1 is 3. -2 plus 1 is -1. So those are my x-intercepts, 3 and -1. All right, so let's put all this info into the graph. I know my vertex is at 1, 4. I know it opens down, and my y-intercept is at 3. And my x-intercepts are at 3 and -1. -1 and 3. And it opens down, so I know it's going to go like this. And there's a pretty decent sketch of my parabola. Everybody okay? All right, so same function. What if I told you at the very beginning of the lecture that the definition of a quadratic function was that you could put it in this form, ax squared plus bx plus c. But we just graphed a function that did not look anything like that, right? X minus 1 squared plus 4 is not in the form something squared plus something x plus c. How could I change this function into this form? Just switch it around a bit. Yeah, we just could do some simplifying. So f of x equals, I've got this negative sign, and then I'm going to square x minus 1. Just do all the multiplication out. X minus 1 squared is x squared minus 2x plus 1. And then I still have the plus 4. Distribute that negative sign, and I get -x squared plus 2x minus 1. And then combine the -1 and the plus 4, and we have -x squared plus 2x plus 3. It's the exact same function written a different way. So let me prove that to you by graphing them both and showing you that they have the same graph. So I go to y equals. Okay, in y1, I'm going to put the original standard form, this -1. So negative times x minus 1 squared plus 4. Okay, so that's my original standard form of a quadratic. And then I just did a bunch of algebra and got something equivalent. So I'm going to put that in y2, negative x squared plus 2x plus 3. And then nifty little thing on your graphing calculator is that I can make this line graph bold by highlighting this little diagonal line and pressing enter. So that second graph will be bold. So then just do zoom 6. So here's the first graph, looks just like the graph we came up with. And then the second graph graphs in bold right on top of it. Okay. And this graph looks just like this one. Exact same graph. Okay. All right. So changing from standard form to this form, the ax squared plus bx plus c, is pretty easy. You just square, distribute, combine like terms, right? Just simplify this expression. Okay, but changing from ax squared to bx plus c to standard form, a times x minus h squared plus k, is a little bit harder. And the trick is to know the vertex, okay? Because a is called a in both equations because it's the same number. Okay, so if you have ax squared plus bx plus c, you know the leading coefficient in standard form. All right, and then if you're given this, all we need to figure out now, because we know a, is we need to figure out h and k. So we have this nice theorem, this little handy dandy thing that tells us that the vertex of a parabola, if you're in ax squared plus bx plus c form, is negative b over 2a, comma, f of negative b over 2a. So that is h is negative b over 2a, and k is what you get when you take that number, negative b over 2a, and plug it into f. So we'll do an example. I have negative x squared plus 4x plus 1, and I want to change it to standard form and graph it. So first, I need to figure out the vertex of this parabola, right? H is the x-coordinate of the vertex, and it's negative b over 2a. Okay. What is b in this quadratic function? 4. So I've got negative 4, because negative b, right? Over 2 times a. What's a in this quadratic function? Negative 1. So I have 2 times negative 1 is negative 2. Negative 4 over negative 2 is 2. And then k, the y-coordinate of the vertex, is what you get when you take h, which is 2, and plug it into f. F of 2. So if I put a 2 into this function f, I get negative 4 plus 8 is 4 plus 1 is 5. I took a 2 and plugged it into this function f. And so 2 squared is 4, so this is negative 4. Plus 4 times 2, 8, right? Negative 4 plus 8 is positive 4, plus 1 is 5. Nope, that's a good question. If there were parentheses around that, that would come out positive. But because then there aren't, that negative is what you do after the square. Yeah. Yep. Okay, so that's the standard form, a times x minus h squared plus k. A is the same, so in this case, a is negative 1. So I just put a negative outside. X minus 2, because, right? The minus is part of the formula. I just replace the h with a 2. and then plus 5 plus k. Does this parabola open up or down? Down, because the a value is negative. Find the y-intercept. How do I do that? Plug in 0. I can plug 0 into the original, ax squared plus bx plus c, or the standard form. I should get the same answer. Plugging into the original is easier because x squared and 4x, when you plug in 0, are both 0. So my y-intercept is 1. And then x-intercepts, plug in 0 for y. So I get 0 equals negative x minus 2 squared plus 5. And subtract 5 from both sides, the same procedure as before, and I get 5 equals x minus 2 squared, which means that x equals plus or minus radical 5 plus 2. And I'll get an approximation for that. Okay, square root of 5 plus 2 is 4.24, and negative square root 5 plus 2 is negative 0.24. So those are my x-intercepts. So now I can graph it. I know my vertex is at 2, 5. 2, 5. And it opens down. And then I can put in the y-intercept and the x-intercept. Y-intercept at 1. X-intercepts at 4.24. Go there, and negative 0.24 about there. And there's one other thing. Thank you. Yes. A parabola has a certain kind of symmetry, right? The vertex, the line that goes through the vertex is like a mirror. So I can take any point that I have on one side and reflect it onto the other. So this y-intercept is 2 away from the axis of symmetry, so I can go 2 in the other direction as well and get another point. Yeah. And then I can draw my parabola. Pretty badly. Not a great sketch. Oh well. So again, let's just show that our sketch is accurate and that you can get it either by graphing the original form or the standard form. So I've got negative x squared plus 4x plus 1 and negative x minus 2 squared plus 5. I'm going to have this second one graph in bold. Graph. And that does look just like the graph I sketched. And the two graphs are on top of each other, which means that they are exactly the same. All right, so far we've been given an equation and been drawing its graph. Can we go backwards and get an equation if you're given the graph? Yes, of course you can. Right. So we want to find the equation of this quadratic function that I graphed here. I want to give both forms, standard and ax squared plus bx plus c. So because they gave me the vertex, which form would be the easiest to start with? The standard form, the one that has the vertex right in it. So we'll have f of x equals a times x minus h squared plus k. So all I need to know are a, h, and k, and I'm done, right? And what is my vertex? That looks like 3, 5. So what is h and what is k? H is 3 and k is 5. Just plop them in, right? So f of x is a times x minus 3 squared plus 5. Okay, so just remember the signs, the minus and the plus, are part of the formula. So you just have to replace h and k with their values. All right, how do I figure out what a is? I know it's positive. That's a great start because it opens up. Nope. Start at 5. Just try putting in 5 for a and see if it graphs the right parabola. Okay, okay. Well, what other information am I given in that picture? You've got the y-intercept and the y-intercept's mirror, right, over the line of symmetry. So I've got some points, right? Points in the form of x comma y. What happens when we're trying to find the equation of a line and you know the slope and you're trying to find the y-intercept? What do? Okay, you could just do slope-intercept form. What else could you do? Oh, that's to find the slope. That's to find the slope. No, yeah, Tony. Put in an x and a y from a point, and then you can solve for a. I know that every point on a graph makes the equation true, so I can plug in and either any point. I have 2 labeled here, but I could pick any point on the whole graph, plug in the x coordinate for x and the y coordinate for y, and then I can solve for a. So I'm going to put in 23 for y, a I don't know, and I'm going to put in 0 for x. I could also put in 6 for x. So then when I solve this thing, I get 23 is equal to 9a plus 5. And then 23 minus 5 is 18, so I get a has to be 2. And it did come out positive, like we expected. Right? So my final equation is going to be f of x equals 2 times x minus 3 squared plus 5. There's my standard form, but they also asked for this form, ax squared plus bx plus c. How do I find it? Yes. No, sorry. Oh, so you thought about it in terms of a vertical stretch? Yeah. Oh, that's great. Yeah, that's good. That's really good. I like that. Okay, so how do I get the other form? How do I change this to ax squared plus bx plus c equals 0? Yep. Square, distribute, and combine like terms. So it's going to be 2 times x squared minus 6x plus 9 plus 5. So I'm just squaring x minus 3. And I distribute my 2x squared minus 12x plus 18 plus 5. And I get f of x is 2x squared minus 12x plus 23. Does that number 23 look familiar? It's the y-intercept. And it makes sense. If I were to plug in 0 for my x's in this other form, I would get 23 as the y-intercept. All right, what key feature of a quadratic function marks its maximum or its minimum? The vertex. So whenever you're asked about finding maximum or minimum values of, and the function is quadratic, you just have to figure out where the vertex is. So here's a vanilla function, no context, just plain old f of x. 4x squared minus 16x plus 1,000. Without graphing, does this function have a minimum or a maximum value? Yeah, it has a minimum value because the a value is positive, which means the quadratic opens up, which means that the vertex is a low point, right? So it has a minimum because a is positive. It would be a maximum, right? Because, yeah, if a were negative, then the quadratic would open down, right? And then the vertex would be at the high point, and that would be a maximum. All right, we want to find the minimum or maximum value and where it occurs. That is the vertex, right? Where it occurs is the x-coordinate, and the maximum or minimum value is the y-coordinate. All right, so how do I find the vertex of that quadratic? Yeah, negative b over 2a. That's the h, the x-coordinate of your vertex. So that's going to be 16 over 8, which is 2. And then how do you get k, the y-coordinate of the vertex? Plug in the 2. So I do f of 2. So 2 squared is 4. Times 4 is 16. 16 times 2 is 32. So 16 minus 32 is negative 16 plus 1,000. 30. 1,000 minus 32. So 9,900. And then, yeah, 984. Thank you. How did I get the 2? Negative b over 2a. So how do I get this formula? Yeah. It's a formula. Yeah, it's from right here. Negative b over 2a. 1,000 minus 32. 968. Okay, I can't trust any of you. Oh, but it's minus 16. Yeah, right. Okay, 984. Thank you. All right, so my vertex is at 984. So let's answer the question the way they asked it. What is the minimum value? Because we know it has a minimum. What is the minimum value of the function? The vertex is at 2,984. But the minimum value of the function is only one of those two coordinates. 984. The value of the function is the y, and where it occurs is the x. So we have a minimum value of 984, and it occurs at x equals 2. So that's how you answer the question. So its minimum value is 984. That's the smallest value that the function hits. What is the domain of this quadratic function? Negative infinity to infinity. You can take any x value and plug it into this formula, right? No restrictions at all. So the domain is negative infinity to infinity. So those are all the inputs. Oops, I shouldn't put that there yet. Those are all the possible input values. What kind of outputs do we get from this function? Well, what's the smallest output we can get? 984. That's the minimum value. That's the smallest output. So that is the smallest. So we put 984 to infinity. We can get anything else bigger than that. All right, so same kind of problem we're going to do next, except this one isn't vanilla. It has some context. Pistachio, yeah. So an archer's arrow follows a parabolic path. That means it looks like a parabola, quadratic. So when you shoot an arrow, it kind of like goes up and arches and then comes back down. And the height of the arrow we'll call f of x, measuring in feet, can be modeled by this function, negative 0.005 x squared plus 2x plus 5. And x is the arrow's horizontal distance. So if I tell you how far it's gone horizontally, you can plug that in and see how high off the ground it is. So I want you to work in your groups to think about A and B. Find the maximum height of the arrow and how far from its release does this occur, and find the distance the arrow travels before it hits the ground. Okay, so what the maximum height of the arrow and how far from its release does this occur? So this is a parabola because it's a quadratic function, so it looks like a parabola. The A value is negative, which means it opens down. So its maximum height is the vertex, right? We find its maximum height at the vertex. All right, so the vertex we can find by doing negative b over 2a. That's the x coordinate of the vertex. So that would be negative 2 over negative 0.01, which is 200. And then k is what you get when you take 200 and plug it into f. And what do you get when you do that? 205. Good. All right, so we have an x coordinate and a y coordinate, the maximum of that quadratic function. Which one of those tells you the max height of the arrow? The y coordinate, because f of x is representing height and x is representing horizontal distance. So I would say the max height is 200 feet. And how far from its release does it occur? It occurs 200 feet from its release point. Right, so the x coordinate, the 200, is the horizontal distance, and 205, the y coordinate, is vertical distance, its maximum height. So how far does the arrow travel before it hits the ground? What do you think? Yeah, how would what equation am I solving? What about k? No, we already know what k is, right? We already know k is 205. Right. I would find an x-intercept. Yeah. Yeah, why do you think that? Okay, so really great reasoning. Shouldn't it just be 400? Because, oh, whoops, sorry, I wrote this. Maximum height is 205 feet. Yeah. So the maximum height, it hits its maximum height at 200 feet, right? So it takes 200 feet, so follow my hand is the path of the arrow. 200 feet and it hits its maximum, right? Another 200 feet, it should be back down to where it started, right? So did it start on the ground? What height did it start at? 5 feet, yeah. Because whoever shot the arrow is 5 feet tall, right? Yeah, so it's 400 feet to get back to 5 feet, and then it's going to go a little bit further. Right. So what I'm going to do is I'm going to set f of x, which is the height of the arrow, to 0. Yeah, that was a good thought, though, Tony. If the arrow had, like, if we had launched it from the ground, that would be perfectly true. Yes. It's that its initial height was at 5 that throws that off. So, but that gives us a good sense of about how long it will take. It shouldn't take much more than 400 feet. So when I solve this, I guess I'll just use the quadratic formula. -2 plus or minus the square root of b squared minus 4 times a times c. And I'll type it all in at once here. Okay, -2 plus the square root of 4 minus 4 times -0.005 times 5 divided by -0.01. So -2.48, that's a negative distance, so that doesn't make any sense. So it's got to be the -2 minus. (402.48 feet. That makes sense. A little bit more than 400 feet. All right, so one more example, maximizing area. This is sort of a classic quadratic maximization problem. A farmer has gone to the farm supply store and he bought 400 feet of fencing. And he wants to enclose a rectangular corral for his, I don't know, cows or chickens or something to live in. And to save money and fencing, he's going to use the bank of a river as one boundary of the corral because his cows and or chickens can't swim. Okay, so we have a river, right? What? Before he bought his 400 feet of fencing, probably, yes. So he's going to build a rectangular corral up against this river. So it needs 3 sides of it have to have fencing. And he's got 400 feet of fencing. And basically he has lots of options of how to build this thing, right? Like, so he could build it so this is, say, I don't know, 100, 100, and 200, right? Or he could build it 50, 50, and 300, right? So there's like a gajillion options of how he could build this. How should we build it to get the maximum area, the biggest area possible? So the only difference between this question and the previous one, this one is a maximize question as well, just like this one was, maximize. The only difference is that this one they gave us the formula. This one we're going to have to come up with it. So if I draw a picture, got my river and my rectangular corral. If I let these two distances be x, right, what's the remaining distance? Close. 400 minus 2x. We have a total of 400. We've already used 2x of it. The remainder is for the third side. All right, what's the area of this corral? Hold on. How do you find the area of a rectangle? Length times width. What's the length of this rectangle? 400 minus 2x. What's the width? X. So there's the area of my rectangle. Multiply this out, and I get negative 2x squared plus 400x. That's a quadratic that opens down, so it has some maximum point. The vertex is going to tell me everything I need to know to answer this question. I could put a plus 0 here if I really wanted that to look like ax squared plus bx plus c. And my vertex, h and k, is at negative 400 over negative 4, negative b over 2a, which is 100. And k is what I get when I plug 100 in there. So 100 squared is 10,000. So that's negative 20,000 plus 40,000 is 20,000. All right, so what do those 100 and 20,000 numbers represent? It's the vertex of the parabola, yep. But to the farmer, what do those numbers mean? Which one's the maximum area? 20,000, yeah. Because it's a y value, right? It's the y value of the vertex. Y is area in our case. So the maximum area that the farmer can have is 20,000 square feet, right? How does he get that maximum area? Should he build the corral? 100 by 300. Yeah, how'd you figure that out? Yeah. 100 is an x coordinate, and x is representing this distance. So if this is 100 and 100, then this would have to be 200, actually. 200. So the corral should be 100 by 200 feet to get maximum area. You get 20,000, exactly, yep. All right, so there's only like 6 minutes left, but you could get a little jump start on this activity, the penny drop.